In this movie, we'll see how we can write a pagination class that can help take a lot of the grunt work out of doing pagination. In the last movie, we were able to get the current page, the records per page, and the total record count, which are the three pieces we need to keep track of in order to do pagination. But we're still not paginating because right now Photograph is still doing find all. What we really need is to do a find by SQL and use our new SQL statement that we saw before that uses limit and offset to get just the subset of records that we want for the current page. Now that's easy enough to do without doing it in an object-oriented way. We could simply do those calculations, compose some SQL, and then do our find by SQL statement. But the benefits of being object-oriented really start to pay off when we start wanting to have other elements on the page, like showing information about the results. For example, results 1 through 10 out of 1,000. We would have to calculate over and over again a lot of information. And then when we got to things like the page links, in order to figure out whether there was a previous link or not, we'd have to do a lot more calculations. And our code would start to get a little messy. And anytime we have that messy code, it starts to be a case where we might think about putting things into a class. And so we're going to start out by doing this in an object-oriented way and creating a pagination class. So I'll open up TextMate and start a new window. Let's go ahead and save this. Inside includes, and it's going to be called pagination.php. And we'll just start our PHP tags. Now, this is just simply going to be a class called pagination, and that's it. It's not going to inherit from anything. It's not going to be using the database. It's just going to be a helper class that's going to help make pagination of our records a lot easier. And one way that the pagination class is going to help us is by keeping track of those three key variables for us: current page, per page, and total count. In fact, since that's going to be its primary role, we're going to go ahead and construct it using those. And we saw how to use construct earlier. We're going to pass it in three arguments: the page, per page, and total count. And in each instance, it's just going to make sure it's an integer and assign it to that attribute. So now it has those stored. So we can't create a pagination object if we don't have those three pieces of information. Now we've given it some defaults, that the default is page 1, that it'll have 20 items per page. You can make it 30 or whatever you prefer. And the total count, I went ahead and just gave it a default of 0. So that you can quickly see how an object-oriented approach like this pays off, let's do a calculation for how many total pages are in our results. We have the total count, and we have the number per page, so we can easily figure out how many pages there will be. So we take total count, divide it by per page, and we take the ceiling, because we want to always round up. We don't want to round down because we'll have some leftover results. And that will tell us how many total pages there are. Now we can simply ask our pagination, hey, tell me total pages. We can also tell it to give us the previous page and the next page. I've put in two more methods here. Previous page, it's current page minus 1. Next page, current page plus 1. Now you could write in some fancier checking for whether or not something has a previous page or has a next page so that we don't accidentally try and go, too low or too high. I'll leave that exercise to you, but I'll add a couple more methods that allow us to ask the pagination from the outside whether or not it has a previous page. So these aren't quite as error-proof as they could be, but we do have a way around it, which is to say, does this have a previous page? And the answer to that is, well, if you take that previous page and it's greater than 1, then yes, there is a previous page, greater than or equal to 1. Return true. Otherwise, false. There's not a previous page. We're at 1 already. Has next page does the same thing, but it uses total pages that we just wrote to say, well, is the next page less than or equal to the total pages? Because if it's more than the total pages, then we don't have a next page. We're at the end already. So hopefully you can start to see why this is going to be very convenient for us to be able to use our object to perform a lot of these calculations without us having to stop and think about it each and every time. One area that's really going to help us is in calculating that offset. That's a little bit complicated. We want to make sure that we get it right. This object will always get it right for us. We take the current page minus 1 times the items per page. And that's the offset. So now we can just ask our pagination object to give us the offset. And if we've provided the 3 parameters, it knows the answer already. Now there's one last step that we want to do. We can save that and close it up. We want to make sure that we go into initialize and just load that up. So core objects, I'm going to put it right here below database object. Make sure that you did load the other ones in here too. User, photograph, and comment. Auto load may be picking those up for you. That may be why you're not getting an error. We have that auto load function. But we want to go ahead and make sure that they get loaded in. And now that that's done, we're ready to paginate, and that's what we'll do in the next movie.